What caused the Space Shuttle Challenger and Columbia disasters? Imagine watching a space shuttle lift off and feeling the excitement of reaching beyond our planet. But sometimes, things go wrong, and those moments turn into tragedies. The Space Shuttle Challenger disaster happened on January 28, 1986. It was caused by a failure in the rubber O-ring seals in the right solid rocket booster. These O-rings are meant to seal the joints between segments of the rocket boosters, stopping hot gases from escaping during launch. On that cold day, temperatures were unusually low, which made the O-rings stiff and less flexible. Because of this, they couldn't form a proper seal, and hot gases leaked through the joint. This leak caused the seals to fail completely, leading to a breach in the booster and the destruction of the external fuel tank. The explosion happened just over a minute after liftoff, killing all 7 astronauts on board. NASA officials and engineers had warned about the risks of launching in cold weather, but those warnings were ignored or overlooked. This decision was partly due to schedule pressures and communication problems within NASA and with contractors. The Challenger disaster showed how critical proper materials, weather considerations, and clear communication are in space missions. The Columbia disaster took place on February 1, 2003. And like Challenger, it was caused by damage to the shuttle's thermal protection system. During launch, a piece of foam insulation from the external fuel tank broke off and hit the left wing of the shuttle. This foam strike created a hole in the reinforced carbon-carbon panels that shield the shuttle from the intense heat during re-entry into Earth's atmosphere. When Columbia returned from space, hot gases entered through the damaged area, causing the wing structure to fail. The damage was not noticed during the mission, and the shuttle's heat shield was compromised. As Columbia re-entered, the heat caused the wing to break apart, leading to the destruction of the entire shuttle and the loss of all 7 crew members. This accident highlighted the importance of inspecting and protecting the thermal tiles and panels that keep the shuttle safe during re-entry. It also showed how debris during launch could cause serious damage, and how important it is to have systems in place to detect and repair such damage if possible. Both disasters changed how NASA approaches space shuttle safety. The Challenger accident made engineers and officials realize the importance of understanding environmental effects like cold weather on hardware. It also led to changes in launch procedures and better communication channels. The Columbia accident emphasized the need for thorough inspection of heat shields and better debris management during launch. It also pushed for improvements in training astronauts to handle emergencies involving damage to the spacecraft. These tragedies taught us that safety must always come first in space missions. They led to new safety protocols, better engineering practices, and more rigorous training for astronauts, all aimed at preventing similar accidents in the future.